you'll want to give to the doctors and nurses first. You don't need physicists to tell you that.
And you need to create new material science, new materials, which comes under the ambit of physical.
This is not 1950s. We have refrigerators practically everywhere.
You know, when you talk about pandemic, the general idea is the only scientists who would matter in the whole process are the people dealing with life sciences. How do scientists who pursue physical sciences figure into this entire force that is driving the research in these COVID times?
As far as the physical sciences are concerned, there are certain areas in which one has to immediately start working on. One is creating a system in which the propagation of the virus is significantly mitigated, which means that you create antibacterial surfaces, the surfaces which require high contact angles so that the virus doesn't stay. And you need to create new material science, new materials, which comes under the ambit of physical sciences. That's one direction in which one has to immediately look at various enclosed spaces, how one can control the surfaces. Okay, that's another direction is understanding the airflow pattern, and that's a very strong area within the physical science in which when you either sneeze or talk or shout, okay, what's the pattern of airflow that carries the virus sufficiently far away? And there's a huge amount of work being done with, again, a combination of fluid dynamics as well as physical sciences, airflow patterns, enclosed spaces, office spaces, where the modeling needs to be done immediately, whereas people are going to shopping malls, cinema halls, and so on and so forth. So there is lots of calculations required, understanding of the particles which carry the virus required. So I can see that immediate time scale, those are the necessities. At the much longer time scale, when the virus is relatively under control, then physical sciences come in terms of combinatorial understanding of the vaccines and many other, even developing the medication for future pandemic.
The more immediate need of physicals or the urgency of physical sciences would be in the kind of vaccine. Now, if you had vaccines that could be stored at room temperature or just say mildly refrigerated, fine, because this is not 1950s. We have refrigerators practically everywhere, and that would not be an issue. Okay, but on the other hand, if it was colder than the ordinary refrigeration, like 5 degrees centigrade or something, yes, we know how to cool stuff, but to do it quickly, effectively under Indian conditions would require rather special refrigeration issues, and that's very much a physical sciences engineering problem. I would say that would be high on my list of an urgency. The second one would be is physicists are very good at modeling. Now you could call this as public health modeling. It's fine. I don't care what you want to call it, but it's a modeling problem. Okay, so if you have enough data which says the people, let's say I need to have some data to do a model which says if you are with these following fundamental parameters, age, okay, then comorbidity factor like you have high blood pressure, or you have diabetes, you have obesity, and so on and so forth, okay. So once I develop a model, it says, given these existing conditions, and now this is a very standard physics problem, given these things, the probability you'll get infected is X, okay? And that's a curve. And if you have that, then in the beginning, until vaccines become very abundant, there's an optimal solution. And that is very much a physics modeling problem. And of course, some of it is common sense, right? I mean, you'll want to give to the doctors and nurses first. You don't need physicists to tell you that. But the next level may not be so common.